In 10c, it's a fourth root, so once again, I call your attention to make sure you look at that index to know what roots you want. So we're going to be finding the fourth root of 32, x to the, a to the 7th, b to the 12th, c to the 10th. So when we do these, with the number 32, now what we want to do is think of, are there any perfect powers of 4 that divide into 32? So I'd start investigating perfect powers of 4. Really, 0 and 1 don't help you. This is 0 to the 4th, this is 1 to the 4th. So the only ones that I'd really start to work on are 2 to the 4th. Well, what is 2 times 2 times 2 times 2? That's a 4 times 4, which is a 16. So 16 is a perfect power of 4, and does 16 go into 32? And, well, yeah, of course it does. It goes in there exactly 2 times. So it's 16 times 2. So the strategy is always to try to find a factor that is a perfect power, and in this case, a perfect power of 4 that divides into 32, and 16 is our number. And now we can write our variables: a to the 7th, b to the 12th, c to the 10th. And now I'm going to take the fourth root of 16. The fourth root of 16 was a 2. We can't take the square root of, or the fourth root of 2 out. There isn't any other perfect powers of 4 in 2, so that stays under the radical. And now we simply start doing our division and see how many groups of 4 are in a to the 7th. Well, there's only one group of 4 in a to the 7th, and we leave 3 a behind, so it's a cubed. And then we go b to the 12th, so that b to the 12th becomes b to the 3rd. There are 3 perfect groups. There are 3 groups of 4 in 12. And finally, we'll take our 10 divided by 4, which gives us a c squared, and that's a total of 8 that we pulled, so we've got 2 left over. Since this was an even root problem, I got to be careful of absolute values. We only want the primary. Since there's nothing here, we just want that positive, so we want to make sure our final result will be positive. So we had an even root of an odd power. We don't have to worry about those. We have an even root of an even power. Well, the even root of an even power with an odd answer requires the absolute value so that we can ensure that this number comes back positive, just as it would have been here. Because it's raised to an even power, they always end up positive. So our final answer would be this result here.